well as the data points. And now, when we look at that, we can see that this appears to be a fairly strong correlation. But now, there is a numerical number for the correlation, and we need to get our calculator to do that. Now, what we're going to do is we're going to set the calculator to give us that number. Now, this is something you only have to do once unless you reset your calculator or turn the diagnostics off. So let's see if we can follow along with me to get this done. Okay, first of all, you have to quit out of the graph here. So press second and then mode, and you'll get back to the main screen. Now, to turn the diagnostics on, we have to go to the catalog of functions in the calculator, because as far as I know, this is not available anywhere else. The TI calculator has hundreds of different functions that it will do, and sometimes you need to be able to access a function. You don't know where to find it. So you can always find it in the catalog, because this is an alphabetical list of all the things that it'll do. Now, you can play with that sometime if you want, but right now, press second and then press 0, and notice we've got the calculator screen on we've got the calculator, the top of the list of the catalog on the screen. Now, notice all of these start with A, and you could scroll down through all the A's and then through all the B's and through all the C's and through some of the C's till you get to the command diagnostic on. Now, we can jump ahead a little bit. Notice the cursor in the top right-hand corner of the calculator screen. It has a little A inside it. Now, that means right now, if you type any of these buttons, the letter that's above it will be the letter of the alphabet that the catalog will jump to. So I'm going to go to D. That's X to the -1. When I press that button, notice it went to the D's. Now, we're not at diagnostic on yet, so we need to go down, scroll down a little bit, but we find it pretty quickly. Now, watch what you do. You press enter, and now diagnostic on is on the main screen. Now, if you press enter again, it says done. Now, if you press second enter, you get back to that line where we had len reg ax plus b L1 comma L2 comma Y1, or you can type all that in again if you want. But now I have this, and when I press it this time, notice besides the 3 lines we had before, we have 2 more. We have r squared and we have r. Now, r squared has some statistical value. We're not going to really talk about that much, but r is the correlation coefficient. So 0.947 is the correlation coefficient for our data set. Now, the correlation coefficient, R, ranges between -1 and +1. Now, as it goes to -1, the correlation gets stronger, but it's a negative correlation. As it goes towards +1, the correlation gets stronger, but it's a positive correlation. And if it's near 0, we say that there's no correlation. Now, we ordinarily say that anything between -1 and -0.85 is a strong negative correlation. Now, between -0.85 and about -0.5, we say it's a weak negative correlation. Between -0.5 and 0.5, that includes 0, we say there's really no correlation. Between 0.5 and 0.85, we say there's a weak positive correlation, and between 0.85 and 0.1, we say there's a strong positive correlation. I wrote that in a different spot, and so we'll just kind of let that go. So we have in this particular case a strong positive correlation. Now, the question now comes up. I'm going to see if I can't save some of this graph. The question now comes up, what if we go to a city that has a population of 50,000? how many Walmarts would we expect or would we predict to be in that localized area? So now what we want to do is we want to predict the number of Walmarts for 50,000 people. Okay, now, if we go back to the calculator and we look at this graph here, what we can do is we can press the trace button. Now, what trace does is it puts you on the dot plots. If you press the right arrow, notice that the little blinker is jumping from dot to dot. Now, we really want the blinker to be on the line. Now, the down arrow will get the blinker on the line. Now, if you press the right arrow, notice it goes up and down the line like we're expecting it to. But now, what we want to know is what y is matched with 50 for x. So if we just type the 50 in at this particular point, notice the calculator accepts that as an x, and when you press enter, it'll tell you y. So we would expect a community with 50,000 people would have approximately 5 Walmarts. Is this a strong, are we confident in this prediction? Well, fairly confident, because the correlation coefficient was high, was close to 1, and we determined from that that we had a strong positive correlation. You too. Now, the okay, now that pretty much takes care of the of this concept. We've talked about bivariate data, the scatter plot, the dot plot, correlation coefficient, strong and weak correlation, positive, negative correlation, the line of best fit, or the regression line, which called from the prediction equation. We've talked about how to get the calculator to do it and given an example. So we're pretty well done here.